Hi, my name is Liam O'Neill, and I'm here to walk you through the first task of the Sparks Foundation Graduate Rotational Internship Program in Data Science and Business Analytics. This task is a prediction using supervised machine learning. The idea is we want to be able to predict a student's score based on the number of hours they study. So we're going to train a model and use it to predict the score of a student who studies for 9.25 hours per day. So we'll start by importing all of the libraries we need to use in the notebook. So we import NumPy, Pandas, and PyPlot. Then we're going to import and inspect the data. So from here we have a link to a CSV file with our data. We're going to create a data frame called study scores and use Pandas read CSV to create the data frame. The head here shows the first 5 rows of the data frame, and we can see that we have some hours and scores, and the values look like we want them to. A little bit more information about the data frame tells us that there are 25 total entries. All the values are non-null, the hours are a float type, and the scores are an int type. So from this step, we can see that since we have no null values, there's only 2 variables, and there's a low number of entries. There's no other data manipulation, data cleaning that we need to do right now. So we're going to inspect the data a little more closely and get a visualization for ourselves. So the describe method tells us a little bit about the values themselves. We can see we have hours here at a mean of 5.01. The lowest value is 1.1 hours and the highest value is 9.2 hours. The scores have a mean of 51.48, the lowest value being 17% and the max being 95%. Now we can use PyPlot's plot function to get a visual representation of the data. So here we have number of hours studied against percent grade, and we can see that there's a positive linear relationship between the 2 variables. Since there's a positive linear relationship, we know that we can do this solving linear regression. So before we can actually take a model and train it on the data, we need to split the data into a training set and a testing set. So we're going to split the attributes and labels apart, so the thing we're using to predict and the thing we are trying to predict. So that is the hours studied to get a score. And we are going to use scikit-learn's train test split to get a training set. And the training set is what we are actually going to train the model on, and a testing set, which we're going to use to evaluate the model. So using Pandas integer locate to split the hours and the scores apart. And then we're using train test split here to get our training and testing set. Now there's 2 more parameters here, test size and random state. So test size of 0.2 just means that 20% of the data is going to be split into the test set. And random state, this value is arbitrary. Encoding a random state just ensures that the numbers don't change every time we run the cell. We want this to be reproducible. So now that we've got our training set and our testing set, we're going to train the model. So we're going to use scikit-learn's linear regression. That's our model, and we're going to train it using the training set data that we have using .fit. From here, I've also printed out the regression coefficient and the intercept because these 2 values are going to be useful, that we're going to be able to visually see what the model looks like against the data. So here I've plotted the regression line against the data that we saw before, and we can see that the model that we have trained looks like it fits the data. But we can evaluate the model a little bit further. So we're going to use it to predict some scores using the test set and compare those to the actual value of scores from the test set. So we'll use the model and use .predict to generate an array of scores. And we're going to compare these scores against the actual values from the test set that we have. So here I've created a data frame that shows this actual score, predicted score. Now our values are pretty close. So the closest one is a difference of less than 1%, and the largest variance is just a little over 6%. So if we're thinking in terms of actual percentage score and accounting for individual variation of how well someone can study, and every person is going to be a little bit different, that makes sense. For a further performance measure, we can use the root mean squared error. So to do this in scikit-learn, we're going to use the mean squared error from its metrics module, and then that'll give us the mean squared error, but we still need to use the square root to give us the root mean squared error. So the output says the model's root mean squared error is 4.3. So what does this mean? It means that we have an error of about 4.3% in score achieved on the test or the exam. So if we think of that logically, that makes sense. That's pretty good. Accounting for individual changes and how well someone can apply their time and what 1 hour means to each individual person, 4.3% doesn't seem so bad. So now we can use this to predict the specific score of a student who would study 9.25 hours. So we're going to use hours studied at 9.25, use .predict with our trained model to get an answer as a score. So for a student who studies 9.25 hours, the model's predicted score is 93.69. If we look at our initial graph and we see that that prediction fits well within the data that we got. So that brings us to the end. If you have any questions about anything that was done in the video or anything that's in the code, feel free to leave a comment or reach out to me directly. Thanks for your time. Bye.